There's a kid that is playing with the ball 13 feet into his rectangular front yard. There's a sidewalk 3 feet wide. You're driving at 25 miles per hour on a residential street that is perpendicular to the kid's driveway. You are getting a phone call and are reaching for that phone when the kid's ball begins rolling towards the street. Your car is 23 feet from where the kid would reach the street if he turned straight toward the street. If the kid heading directly towards the street is 0 degrees, then the ball is rolling at an angle of 40 degrees to the right. The kid is 2 feet behind the ball, both traveling at a constant rate of speed, 12 miles an hour. If nothing changes, are you going to hit this kid? How long before they hit the street? The first thing that I want to do is lay out a general, again, non-artsy sketch of what's happening. You have a car that's going forward. It's going straight down the street. You have a kid that's off to the right, we'll say, and the ball is going to be heading at an angle from straight and to the right. That's 40 degrees. All right, and the ball is, and the kid, of course, are eventually going to hit the street. So once that's done, then I need to go on and label my diagram, putting the information that I've been given from the problem into it. You've got the 3-foot sidewalk, you've got the 13 feet deep, you've got the vehicle going 25 miles an hour, and the 23 feet from where the kid would hit the street if they went straight or directly towards it. All right, if they can't catch that directly towards something means you are heading straight at it perpendicular, then just take a marker and demonstrate. Being that we do not have the hypotenuse or the opposite side measure, you cannot use sine. So let's use cosine first. Use the cosine of 40 degrees is equal to the adjacent, which is 16 over the hypotenuse. Once you do that, you should find out that your hypotenuse is 20.89 feet. Next thing you can do is go and use tangent, and you can find that the tangent of 40 degrees is opposite over 16. You're going to multiply both sides by 16, and you'll end up with 13.43. You want to check your work. Have them check their work. You don't check their work, so show them how to. In this case, I just used the Pythagorean theorem to verify that everything is balanced. So you take your 13.43 squared, you add that to your 16 squared, and then you take the square root of that number, and you still get 20.89. That's how you know you're correct. Now that you have the distances filled in for the sides of the triangles, you can insert this back into your diagram. All right, let's go on and note that you have the car, which needs to travel through the point where the kid would hit the street if you turn directly towards it, and the point that's to the right of the kid where the ball is going to hit the street, and that's also going to be where the kid is going to hit the street. So the car needs to get to that point as well as the kid needs to get to that point. You know what distance, you know what angles, and the thing is do they get there at about the same time? Once you got that, you need to make sure all of your units match up. The proper units for this would be feet as regards to distance. Miles will be way too big of a measurement to use for someone just in their own front yard. All right? And in terms of time, okay, you don't have minutes to make decisions when it comes to driving and making safe driving decisions. You have matters of seconds. You have split-second decisions to make for paying attention. So you need to convert all distances to feet. Time is not really an issue, so the speeds or the velocities also need to be in feet per second. So let's make that conversion happen. By converting, you took 25 miles over 1 hour, then 1 hour over 60 minutes. Notice that since hours was on the bottom the first time, it needs to be on the top the next time, and they're going to cancel out. So now that hours is gone, you want to get minutes to be gone. So minutes was on the bottom, that second fraction, now it's on the top and the third. And then you have seconds that's left on the bottom. last but not least, you'll go on and cancel out miles. Since it's 25 miles, that's on the top. Then the next time you use miles, it needs to be on the bottom. And 5,280 feet is 1 mile. You'll go on and let that happen, multiply it out, then divide. You get 36.67 feet per second. Once you have the speed in feet per second, now you have a velocity in feet and you have a distance in feet. You want to put that together. Remember, if you know what to say when you ask someone what's the speed in miles per hour, like what's the speed limit on the street, then you know what the formula is for speed. You say miles per hour, miles being a measure of distance, per meaning division, and then hour being a measure of time. So since you know that velocity is distance over time, then you can switch out the numerator on the left and the denominator on the right, and what you end up with time is distance divided by velocity. Once you do that, you found out that that car, because that person was not paying attention to the road, alright, is going to be at that spot in 1 second. 1 second. Tick, tock, tick, tock. That's very important for you to think about. That's why that no texting while driving is so important. You always want to pay attention. Nobody's perfect with it, but just do the best that you can do. Once you know that the car gets there in 1 second, you need to find out, is the kid there at the same time? So what you're going to do is convert that 12 miles per hour into feet per second for the kid. Once you find that out, again, same process, you get 17.6 feet per second. You take that 20.89 feet and you divide that by 17.6 feet per second, and you find out that the kid gets there in 1.19 seconds. That's only a difference of time, which means you subtract those two times and you find out the difference of time is 0.19 seconds. Now, whereas that doesn't seem like a big deal, you have to make sure and fully understand that that's pretty much darn near instantaneous. Alright, it really doesn't get much closer than that. This is Charles Edgar Hampton, just wanting to say thank you for listening, thank you for watching. If these videos are ever helpful to you, please do give me a thumbs up, like it, add it to favorites, however you want to do it. Share it with your friends if you have some friends that are struggling, or if you know some people struggling with either physical science or physics or math, or some teachers or whatever that want some challenging problems. Fork it on over to them. Peace and blessings.